Hello there, and welcome to the Dark History channel. The ground beneath your feet feels solid, still, almost unmoving. But deep below the surface, our Earth is in constant motion. It's a slow, silent dance that has been happening for billions of years. This process is called plate tectonics, and it's the hidden force that shapes our world. It builds majestic mountains, carves out vast oceans, and is the reason behind powerful earthquakes and volcanic eruptions. In the next few minutes, we're going to take a journey deep beneath the Earth's crust to understand what plate tectonics is, how it works, and why it's absolutely essential for life as we know it. Let's begin our adventure beneath the surface. So, what exactly are these tectonic plates? Imagine the Earth's outer shell, called the lithosphere, isn't one solid piece. Instead, it's fractured like a cracked eggshell into massive, rigid slabs of rock. These are the tectonic plates. There are 7 major plates like the Pacific, North American, and Eurasian plates, and many smaller ones scattered around the globe. Some of these plates carry entire continents, while others form the floor of our oceans. These giant plates aren't just sitting there. They're floating on a hotter, softer, semi-molten layer of rock just below, known as the because the asthenosphere can flow like very, very thick honey. The plates on top can slowly drift. How slow? About the same speed your fingernails grow, just a few centimeters per year. It might not seem like much, but over millions of years, this tiny movement can shift continents. But what gives these massive plates the push they need to move? The answer lies deep within the Earth's core. The core is incredibly hot, generating intense heat that rises through the layer above it. The mantle, this rising heat creates slow-moving convection currents, similar to how water circulates in a boiling pot. Hotter, less dense material rises, and as it cools near the surface, it becomes denser and sinks back down. This continuous, circular motion in the mantle acts like a giant conveyor belt, gently pushing and pulling the tectonic plates that float on top. It's a steady, powerful, and ceaseless process that has been reshaping the face of our planet for eons. This movement leads to some very interesting interactions where the plates meet. We call these areas plate boundaries, and there are 3 main types. First, we have divergent boundaries. This is where 2 plates are moving away from each other. Think of it like a seam slowly splitting open. This most often happens on the ocean floor. As the plates pull apart, magma from the mantle rises up to fill the gap. It cools and solidifies, forming new crust. This process is called seafloor spreading, and it's how oceans grow wider over time. In fact, the Atlantic Ocean is still expanding right now because of a massive divergent boundary running right down its middle, known as the Mid-Atlantic Ridge. Next, we have convergent boundaries, where plates move toward each other. What happens here depends on the types of plates involved. If a dense oceanic plate collides with a lighter continental plate, something has to give. The heavier oceanic plate will bend and slide beneath the continental plate, sinking back into the mantle. This process is called subduction. Subduction zones are hotspots for geological activity. As the plate sinks, it melts, creating magma that can rise to the surface and form chains of volcanoes. These zones also create the deepest parts of the ocean, called trenches, and are responsible for some of the world's most powerful earthquakes. But what happens when 2 continental plates collide? Neither is dense enough to sink. Instead, they crumple and buckle under the immense pressure, pushing upward to form massive mountain ranges. The majestic Himalayas, home to Mount Everest, were formed this way when the Indian plate crashed into the Eurasian plate. And believe it or not, they're still growing taller today. Finally, there are transform boundaries. Here, plates aren't moving apart or crashing together. They're sliding horizontally past one another. At these boundaries, crust isn't created or destroyed. However, the movement isn't smooth. The rough edges of the plates can get stuck, and as they continue to try and move, immense stress and tension build up over years, decades, or even centuries. Eventually, the pressure becomes too great, and the rocks slip suddenly, releasing all that stored energy in an instant. The result is an earthquake. The famous San Andres Fault in California is a perfect example of a transform boundary, where the Pacific Plate is grinding past the North American Plate, causing frequent seismic activity in the region. Because of all this activity at the boundaries, it's no surprise that most of the world's earthquakes and volcanoes occur along these lines. If you look at a map of global seismic and volcanic activity, it almost perfectly outlines the edges of the tectonic plates. These events aren't random. They are the direct result of the Earth's natural process of releasing heat and pressure from its interior. While they can certainly be destructive and pose significant risks to communities living nearby, they are also a fundamental part of how our planet functions, constantly renewing its surface and shaping the landscapes we see around us. So why does all this movement matter? Well, plate tectonics is a key ingredient in making Earth a habitable planet. It acts as a global thermostat. The process of subduction helps recycle carbon from the atmosphere and ocean floor back into the Earth's mantle, which plays a crucial role in regulating our planet's long-term climate. The formation of mountains influences weather patterns, creating rain shadows and directing airflow. Volcanic activity, while dangerous, also brings nutrient-rich minerals to the surface, creating incredibly fertile soil for agriculture. Without the constant churning and recycling driven by plate tectonics, our planet might be a flat, water-covered, and ultimately lifeless world. So, even though we can't feel it, the ground beneath us is alive with motion. Continents are drifting, mountains are rising, and oceans are constantly being born and consumed. Plate tectonics is a beautiful and powerful reminder that our planet is not a static rock, but a dynamic, breathing system. It's a slow, relentless force that has shaped our past and will continue to shape our future for millions of years to come. Thanks for joining me on this journey beneath the Earth. If you enjoyed this video, be sure to like and subscribe for more explorations into our amazing world.